Hello everyone. Today I'm going to show you how to use the regression line to do prediction. So the first example I'm using is this 5 pairs of shoe print lengths and heights to predict the height of a person with a shoe print length of 29 centimeters. So this is exactly the same data set we used in the previous session. And if you are curious, it's this data set shown here. Okay? And if you have that in statcrunch, yes, as this variable 1 and variable 2 here, you can find the regression line by go to stat regression, simple linear. So choose x to be variable 1 and y to be variable 2. And if you compute, this will give you the regression line. So you really don't need your formula. So this is like variable 2, in other words, y equal to 125.4 plus 1.73 times variable 1, in other words, x. Okay, so if you want to know the value for the shoe print length of 29, you want to really plug in this 29 as your variable 1. But for this case, it is not like that, because firstly, you need to identify that your variable 1 and 2 are indeed linearly correlated. So how to do that? As we said in the previous session, we look at this line of slope and look at this p-value. This p-value is 0.2937, which is too big. It's bigger than, say, 0.05. So by the knowledge of the previous session, we know that we fail to reject the null hypothesis. So variable 1 and variable 2, we don't really say that they are linearly correlated. So even though we have the regression line here, we cannot really use that for the prediction. In this case, what you are going to use is just the y bar. In other words, the average of all those values here in column 2. So you go to stat, summary stats, columns, you get the average of this, or say the mean of this variable 2. So this mean of variable 2, which is 177.3, would be your predicted y value, or say predicted height. This is where this value is coming from. Okay, that's the first example. The second example, I'm going to use 40 pairs of shoe print lengths from dataset 2 in Appendix B. And again, you want to predict the height of a person with a shoe size of 29 centimeters. Okay, so for this data set, I find it here. So for the shoe print and the height, we have 2 columns of data. First, again, you need to go to the regression simple linear. You have your x as the shoe print and y is the height. And if you click compute, you will get a lot of information here. You have your regression line here up here, okay? But again, first you need to make sure your x and y, or say your shoe print and the height, are indeed linearly correlated. So what you're going to do is go to this slope line and look at the p-value. This p-value is less than 0.0001, which is pretty small. That means your shoe print and the height are indeed linearly correlated. So you can use your regression line here. Okay, so if you know your shoe print is 29, you can simply plug in 29 here. So the height would be 80.9 plus 3.22 times 29. Okay, so this is how you can use your this equation here, plug in x equal to 29 to get the predicted height, or say predicted y value.